When I put this on the board, as you can see in front of you, I think a lot of you would know exactly what the answer is. Without me saying anything else, I think there are some of you who would be able to come up with an answer without me telling you anything specific about how this gets done, right? If you had to guess your answer right now, well, what would your answer be? The log of some value of x plus 4 equals 1. What is x? Okay, so a bunch of you already come in with 6, and you're absolutely right. And you already know that this is a base 10, right? Even though the base isn't explicitly stated, you knew this was a base 10. So you said, okay, if the log base 10 of x plus 4 is equal to 1, then I can write this in what we call exponential form. Exponential form means that I'm going to take the x plus 4. I'm not sure why I'm using green. I'll change that. I can take the x plus 4 and set that equal to 10 to the power of 1. That's my exponential form right there. And of course, since 10 to the power of 1 is 1, that means that x plus 4 is equal to 10. And by just simple algebra, x equals 6 would be my final answer. So you might have done that by just simply inspection, by just looking at it and thinking, the log of something plus 4. Well, the log of 10 gives me 1. So therefore, it must be that it is 6 plus 4 that gives me that 10, and therefore x is equal to 6. So there you go. Nice, simple way to start that one off. How about this one? The log base 5 this time of 2x minus 3 is equal to 2. Well, the base is different, obviously, than the one we did before. The base is now explicitly said to be 5, but we can do the same thing we just did, which is we can put this in exponential form. So taking away the log would mean that I would have the 2x minus 3, but now we're equal to not 2 anymore, but 5 to the power of 2. The base raised to that number that was expressed as being the log, 5 to the power of 2. All right, so we can finish this up. So 2x minus 3 is equal to 25. Right, that's what 5 squared is. And 2x is therefore equal to 28. And of course, that does mean that x equals 14. Now, I should warn you that one of the things you want to do when you're solving log equations is always compare your answer against the original equation. It has to be original equation. There are times when, and you will get some of those questions in a minute, there are times when that answer that you get is what we call extraneous. And all extraneous means is that, yes, algebraically, it makes sense for that to be an answer, but it doesn't work with the original equation because maybe you had to find the log of something that was negative, for instance, and we know we can't take the log of negative, or you have to find the log of 0, which does not exist. So one of the things that you need to be careful of is that your answers are not extraneous. Well, 14 works fine. 2 times 14 minus 23, well, 2 times 14 is 28, minus 3 is 25. The log base 5 of 25 is equal to 2. So this answer is perfectly legitimate. So it's good. All right, so this answer, we can accept it. But what about when the question looks like this? Uh-oh. The log of x minus 1 minus 1 is equal to the minus log of x plus 2. This isn't quite like the one we had before. Factor, Eva is thinking. But how would you factor that though, Eva? Tell me how you would factor. I'm curious. What's the common factor that you're seeing? And I like what Ava is doing. Ava is at least thinking about the question. Rather than just sitting there looking at the screen, which unfortunately some people do, Ava's actually thinking about the question. Okay, add the right side to the left, Ava is thinking. I don't know. We can use the log base b log. Okay, so Jeremy is thinking that maybe you can use the change of base. All right, so Noah, can we combine the logs? They have the same base. Okay, I like a lot of those ideas. I'm going to go with what Ava just suggested. I'm actually going to put all my stuff with logs on one side. So I'm going to say the log of x minus 1 plus, I'm bringing this over on the other side, and I'm bringing this over to this side, plus the log of x plus 2 is equal to 1. Does that make sense, everybody? Right? So I put all the logs on one side. So the log of x minus 1 plus the log of x plus 2. I took the negative log, which was on the right, and switch over to the left. I know, of course, it's positive. I took the minus 1 that was on the left, and I put it on the right. Okay? All right. Well, what else can we do with what's on the smartboard right now? All right? How can we simplify this further? Now, I saw somebody said something earlier on. No, I don't think anybody used what I was hoping to say. All the logs are together. Noah did suggest that. They have the same base. That's good. Because they have the same base, is there any way that I can perhaps combine them? I'm just throwing that out there as a suggestion. The log of x minus 1 plus the log of x plus 2. Okay, so Noah is saying multiply, and Jeremy wants to say what? Yes, Jeremy. So that product law of logs that we learned a few days ago. So the log of the x minus 1 times the x plus 2. That's the product law of logs right there. And that's, of course, equal to 1. All right? So Noah is right. Jeremy is right. Right? The log of a sum is the same as the log of the product. Right? The product of the x minus 1 and the x plus 2 could have been written as a sum. In fact, it was written as a sum. We've now chosen to write it as a product. Okay, Kale, please go ahead. Kale, you had your hand up. Please go ahead. Oh, okay. All right. Keeps doing that. All right. Okay. All right. Okay. So I'm going to continue then. So what do you think I'm going to do now then? What do you think might be a good idea now that we've put them all together into one log? Now what? Okay. So solve how? How do we solve from here then, Harish? All right. We've done that. Change it to two brackets. Multiply the two brackets in the log. Okay, let's do that. So it's the log of, so let's see now, that's going to be x squared, then minus x plus 2x minus 1 equals 1. All right, all I'm doing there is I am doing FOIL and multiplying the two brackets out as Jeremy suggested. Let me simplify that a little bit or collect my like terms. So x squared plus x minus 1 equals 1. Right? I just simply combine the minus x and the plus x together to give me plus x. All right? Minus 1 or, oh, yes, thank you. Thank you very much. That is absolutely correct. What I just wrote down is rubbish. And what I should have is minus 2. Noah is right. Noah is right. All right. Okay. So now that I've done that, now that I've corrected myself, thank you, Noah. What happens next? What happens now? So I multiplied it out. The log of this looks like a quadratic is equal to 1. What do I go? Where do I go next? We still haven't solved for x. So I need your help. I need your help. What Harisa has just said. What did Haris say? Oh, change to exponential form. Okay, good, good. Let's do that. So an exponential form being a base 10, it means that x squared plus x minus 2 should be equal to 10 to the power of 1 then, in that case, which, by the way, is equal to 10. So here's what we have. We have x squared plus x minus 2 equals 10. Exponential form. Jeremy said it best. Keontae also said that, and Ava also said that, right? And Arisha apparently had said that earlier on. So I've done that. Still don't know what x is. Move the 10 to the left. Okay, I can do that. So x squared plus x minus 2 minus 10, I guess, is equal to 0. And the whole goal here, as Ava recognizes, is that we want to make this thing into set it equal to 0 because it's a quadratic. And by the way, we can simplify this. Let's just simplify this some more. X squared plus x minus 12 equals 0. So, of course, use the x method to factor. I don't really need the x method on this one, Jeremy, because remember that the x method is only really necessary when there is a number other than 1 in front of the x squared. So we can just factor this in the regular shortcut way, right? Can anybody tell me what those factors would be, right? Okay, so Ava is saying x plus 4. Why is there an extra x on the outside of that? All right, x plus 4, x plus 4. Oh, I think I see what you're doing there. I understand what you're doing. X plus 4x minus 3. So that would be the first step, Ava, for you to get the final answer. But the final answer would be this. Would you agree with that, by the way, Ava? Does that make sense to you? And everybody else? Okay. So x plus 4 and x minus 3, which would suggest that x has two values, minus 4 and 3. Now, I mentioned to you first a few minutes ago that you can get an answer or answers, and the answers or answer is not valid. It's extraneous. Does minus 4 work? Does 3 work? Are these answers numbers that we can live with? Let's go back and have a look. The original question said log of x minus 1. So if I were to use minus 4, I'm going to get the log of minus 4 minus 1. It's going to be a bit of a problem, right? And if I try that even in the second bracket, I'm still going to have a problem. Minus 4 plus 2 is still not going to work because minus 4 is going to give me a negative log. Well, okay, so we're going to toss out. We're going to toss out the minus 4. Can't work. How about the 3? Let's see if the 3 is any good. I'm going to have 3 minus 1. Oh, that's okay. I'm going to have 3 plus 2. Oh, that's okay as well. So guess what? The answer is that, let me put that in black actually. The answer is that x is equal to 3, and in brackets I'm going to say minus 4 is extraneous. And all that means is that it looks good, but it's not going to work. It just does not satisfy the condition of the equation itself. So therefore, minus 4 is actually extraneous, as Jeremy has rightly said. So there's my answer. It's only equal to 3. Now, and I should still check if 3 actually does work, not just does it work. Now, if I took the log of 2, 3 minus 1 is 2, and minus 1 from it, is it the same thing as the minus log of 5? If you try it on your own, right? It actually does work. So the log of 3 minus 1 is 2 minus 1, and then try finding the minus log of 5 and see if you get the same thing on both sides. You will, but I'm going to leave you to do that on your own time. Okay? 3 does work. 3 is a valid solution. How about this one? The log, oh, let me see if there's another question on this page first. Hang on a second. No, there wasn't. Okay. How about this one? The log of x cubed minus the log of 2 is equal to the log of 2x squared. Jeremy has his hand up. Please go ahead, Jeremy. Go for it. Okay. Okay. Okay, let's do one part at a time. What does that give you by using the quotient law? So x cubed minus the log of 2 would give me what? Okay, so what is the quotient law again? Okay, so let me repeat what the quotient law says. Excuse me. And I see your answer, by the way, Jeremy. Quotient law, Ava, says that if I take the log of a difference, as I'm doing here, the log of x cubed minus the log of 2, I can replace that and express that as a log of the quotient of the two things that I was taking the log of. So instead of saying x cubed minus the log of 2, I could say what I'm about to write down now, x cubed over 2, because those are equivalent, is what I'm saying, is the quotient law. Okay, Ava? Hopefully that rings a bell. All right. On the other side of that, we had that that was equal to the log of 2x squared. Now, Jeremy was saying, why don't we bring that log of 2x squared over to the left-hand side, and maybe we can do another combination of those two. Well, there's another thing what we could do, though. I agree with you. All pass. Okay, very quick. Okay, Jeremy. I agree with you, but I want you to look at this another way. I have the log base 10 of something on the left is equal to the log base 10 of something on the right. They're both base 10 logs. What do you think I might be able to do with that case? Anybody? They're both logs on both sides. Think of other questions that we've had with a similar operation on the two sides of the equation. Cosine of this equals the cosine of that. Move them to the left. No, I'm thinking of something else. Remember back when we had, I'm going to give you an example of something that we did in our trigonometry unit. The cosine, I'm just going to make something up on the fly here, of x plus 5, not sure why it's a square bracket and a round bracket, is equal to the cosine of, let's just say, 6. What did we do in a case like this? Or, let me show you something else. 2 to the power of x plus 5 is equal to 2 to the power of 3x plus 1. What do we do in a case like that? Cancel out the base. Cancel out the log. Okay then. Okay then. So let me go ahead and erase all of this stuff because I think people are beginning to see exactly what we could do. If these are both base 10 logs, they're both base 10 logs, what that means is that I can just say, since they're both the same base, that means that x cubed over 2 is just equal to 2x squared. That's what we're saying, right? Right? That is what we're saying. Now, if they were not the same base, we couldn't do that, right? But they are the same base, so we can do that. Okay. What do you think would be another step now at this point? What do you think would be a good next step? Could we have done that with the last one? Okay, well, let's take you back to the last one for a second here. On this one, it was, when we got to this point here, it was the log of this is equal to 1. So it wasn't that the log of this was equal to the log of that. It was that it was the log of something was equal to a whole number. So I'd have to say, Harish, no, that one had to be done differently. All right, do you see what I'm saying, Harish? That's a different kind of approach for this question compared to the one that we're doing right now. Does that make sense to you, Harish? It wasn't that there was logs on the left and logs on the right, not that way. No, at the beginning, we still had, yeah, log on the left, log on the right, but there was this one that didn't have a log on it at all. All right, okay, let's move on. So now we have this, and Jeremy was saying multiply both sides by 2. I actually like that idea, so I'm going to do that. It's like cross multiplication in a sense. So 2 times that, okay, so that means that x cubed is equal to 4x squared. Right? Like, what is this law's name? You're saying the law. There is no law really. All we're saying is that you have the same operation on both sides. Here, I mean, I'm sorry about quite off top. What is this? Log b over log. Oh, that's a change of base. That's a change of base formula is what that is. All right. We don't need that here though. We don't need that here. So let's keep going. So x cubed is equal to 4x squared. Do we know how to solve this? X to the power of 3 is equal to 4x squared. Do we know how to solve this? Move everything to the left. I actually think that's a great idea. I can tell you that some people would say, why don't we divide both sides by x squared? That would work, but that would make you miss one of your solutions. So what we're going to do is we're going to do exactly what Jeremy just suggested. X cubed minus 4x squared is equal to 0. Right? It's always generally a better idea when you're solving a polynomial to try to set everything equal to 0 if possible. Okay? So factor out, Ava says the x squared. I think we should do that. We're going to do exactly that. And what's left when I factor out, as Ava just said, that x squared? What's left inside of the bracket when I factor out that x squared? So the x minus 4, good. So now we have the potential for a solution, right? Remember, zero product law says if I multiply two things to get 0, one of those things has to be 0. So either x squared equals 0 or x minus 4 is equal to 0. That's the only way to get 0. If one of those things is 0, either the x squared or the x minus 4. Well, the left-hand side gives us what solution? What does the left-hand side give us as a value of x? What is x equal to? And what about the right-hand side? What does that suggest that x is equal to? X on the left, good, is 0. X on the right is 4. So there are two solutions to this. But are they both valid? Let's go back and look at the original equation again. This was a log of x cubed minus a log of 2 is equal to log of 2x squared. Can 0 be considered to be legit? Can 0 go back into the equation? Well, x cubed would be 0 cubed, and that would be the log of 0, which is I can't do that. Over here, I have the same issue. 0 squared is 0 times 2 is still 0. No, not going to work. So guess what? I'm going to have to scratch this answer. But I can still accept this answer. So x equals 4 is good. But in brackets, I might want to write that x equals 0 is extraneous. If the question said to state any extraneous answers, this would be one of them. Or this would be the extraneous answer. No can do. Looks good on paper, not so much when you try it out in the original function. Okay? All right, I think we're doing really well. I might be able to at least get started on solving exponential equations as well, but we'll see how far we get with this. How about this one? Well, that doesn't seem too hard. We did one like this just a few minutes ago, right? The log of k plus 2, except that this time we're adding these two together. Actually, no, it's the same thing. We're adding these two together. So this one shouldn't really be too difficult at all. I should have to turn this over to the class and say, you do it. Well, tell you what, we'll just rush through it very quickly then. It's the same as the log of, I'm not even going to bother to ask you, the k plus 2 times the k minus 1 is equal to 1. Again, it's still a base x equals k. X equals k. Yeah, I'm using k instead of x. Yeah, right. Is this not the one exact? Is it really? Let's see if it is. I hope it's not. K plus 2, x plus 2, x minus 1. I think it does. It might. Yeah, you know what? Let's just skip it then. I'm not sure why I have it there. Not sure why I have it there. Okay, let's try this one. I'll take that out. It's just rearranged. Yeah, you're right. Seems familiar. Yeah, it does. Let's do this one then. Log of p plus 5. Now it's minus p plus 1. That's equal to 3. Okay. So how else can we write this question is what I need to know. how else can I write this question? The quotient law for the logs. And the quotient law, it was asking earlier on, says that if I take the log of a difference, it's the same as the log of its quotient. So it's the same as the log of the p plus 5 over the p plus 1. That's equal to 3. Oh, sorry. Didn't mean to do that. Hold on there. Let's leave it as it is. All right. So Jeremy's right. What else? What do we do now? Not Jeremy all the time, folks. Need some other help from other people. What else do we do now? All right. So the log of that over that is equal to 3. Where do we go next? What happens next? Hang on, Jeremy. Okay, so at least one other person chipped in. So Ava is saying us. So what does it look like in exponential form then? What does this look like in exponential form? And by the way, I'm going to say you're both right. Right? It is the exponential form that we need to look at now. So what does this look like in exponential form? So thank you, Ava. So the p plus 5 over the p plus 1 is equal to 10 to the power of 3. Nice. Okay. Now what? Okay. That was good. That was good. And by the way, 10 to the power of 3 is 1,000. It's a 1 followed by 3 zeros. Okay, that's nice. But what's the value of p? How do I move from that to find the value of p? So p plus 5 over p plus 1, cross multiply. All right. And Jeremy's raising his hand as well. So, okay, so he's agreeing with Harish. Let's put the 1,000 over 1 then to see how that works. So this bottom of this fraction multiplied by the top of this fraction, that multiplied by that is what we're about to do. Okay, so it's going to be 1,000 times p plus 1 is equal to p plus 5. Okay, 1 times p plus 5 is just p plus 5. Or 1,000 p plus 1,000, I'm just expanding that, is equal to p plus 5. And now I just have to get my p's together. So 1,000 p minus p is equal to 5 minus 1,000, right? I just simply put the p from the right-hand side over onto the left-hand side and subtracted it. So the 1,000 minus 1 is equal to 5 minus 1,000. I'm hoping everybody's okay with that. Yes, Caleb? Okay, 5 minutes, please. All right. So, well, 1,000 minus 1 is 999 p, and 5 minus 1,000 is minus 995, which means that p is equal to minus 995 over 999. Now, that number looks maybe like it could be a little suspicious because it's a negative number. And I'm thinking, I don't know, right? Is this something that we can work with? Let's go back and look. And this is approximately, right? Just approximately a little bit less than, if you put it on your calculator, it should be negative, I don't know, well, let me put it on my calculator. 995 divided by 999 gives me approximately 0.995, negative. Negative 0.995. Okay, so I'm thinking, I don't know. Does this answer, because we didn't like negative numbers before, is that going to be a problem? Well, add it to 5, that's not too bad, right? It's negative, but it's not as big as 5. So it means that if I add it to that, I should be okay. How about the plus 1? This number here is less than 1. So adding that to 1 is that going to cause us to end up with a negative? What do you think, folks? All right, 996. I think you're right. 996. Yeah, yeah. My rounding is off. Is that going to cause this to be a problem? Right? Right? Is putting it plus one going to lead to a negative number? It's not extraneous. No, it's not. So the answer is in fact a valid answer, right? 0.995 works. I think it's 0.995995995. I think that's what it works out to be. But at any rate, I wouldn't even put this as the answer, right? I wouldn't use this. I would say use this instead. Use the exact form. That's the answer that I'd like to get from you, right? The minus 995 over 999. Okay. Yeah, once you start rounding answers, it means you're losing some of the accuracy of those answers. Okay, what else we got? Oh, okay. How about this one? Now that I've done another question before, I think you would probably know exactly what to do with this one. The log of x squared minus 5x is equal to the log of 6. Okay. Okay, so what do I do then? Drop the logs, no, it's saying. Drop the gloves, okay. Cancel out the logs, I'm hearing. Axel, Isaac, and Sharisa. All right, so you're right. You're absolutely right. I can simply say that x squared minus 5x, as long as the two of them are the same, is equal to 6. All right, when I say the same, I mean they're both the same base. If they weren't, and there was a question that I had on an assignment that wasn't, and it took quite a bit of steps for us to get to it. But let's just say that it was the same base as it is in this case. I sense something bad is going to happen with this question. What? I'm not sure why you're saying that. And Travis is agreeing with you? Really? I don't know why that. I don't know why that dread is there. But anyway, let's keep going. So I'm hearing that I should take away the 6 from the two sides, make it equal to 0. Right? No one gives us a question this easy. Is that right? Oh, I see the trick. There's no real trick here. I mean, the fact is that now we have to solve for x the way we solve any other quadratic. Right? X squared minus 5x is equal to 6. That's the first thing. Get rid of the logs. Now we have to factor this. And can somebody help me with factoring this, please? Right? What are the factors that would make this work? There is no trick here, folks. I'm getting two different answers. I'm getting x plus 1 and x minus 6. I'm getting x minus 3 and x minus 2. So somebody's right, somebody's wrong, or you're both wrong. I'm not sure. You can't both be right. All right. All right. So I'm going to go with the x minus 6 and x plus 1 approach. Okay? That certainly makes more sense. X minus 6 and x plus 1, which means that x is both equal to 6 and x is equal to minus 1. Now the question is, are both of these answers legit? Can 6 work and can minus 1 work? Okay, Janaya is saying yes, meaning what Harish is thinking the minus 1 is extraneous. Well, let's find out. Let's find out. I'm going to put them both into the original equation. So it's the log of minus 1 squared, right? Minus 5 times minus 1. That's what we're trying to do here, Harish. Okay? Now, minus 1 squared is just simply 1. Minus 5 times minus 1 is plus 5. So guess what? This is the log of 6, which, by the way, is what we said this was equal to. So it's equal to log of 6. So that's good. That seems fair. All right, so nothing wrong with the minus 1. How about the next one? Next one should be, we said 6. So that should be the log of 6 squared minus 5 times 6. Well, that's going to be equal to the log of 36 minus 30, which is still 6. So guess what? Both answers are good, right? Both answers are acceptable. Right? Nothing wrong with it. Don't ever jump to the conclusion that a negative answer is automatically extraneous. You should always check your answer at the end, right? Because it may be that the answers are both right, or they're both wrong. They could be both wrong, or just one of them is wrong and one is right. So just check your answer at the end. Do we really need to do this one? All right, we'll just take a few minutes and get this one done. This is very similar to the one we had before. So 3x squared is equal to x, right? Take away the logs. 3x squared minus x equals 0. Factor out the x, and you would end up with 3x minus 1 equals 0. I know I'm going fairly quickly because we did one like this before. So we should have two answers here. X equals 0 and 3x minus 1 equals 0. So therefore, x equals 0 is one answer. The other answer is x equals 1 over 3. Okay? And are these answers both acceptable? Well, you tell me, folks, before we move on. Are these answers both good? Or is one not so good? What do you think, folks? Both good or one good? So the x equals 0 is good, x equals 1/3. What do you say to that? Okay, I need some reaction from the room on these answers. 0 doesn't work, 0 is extraneous. Okay, how about the 1/3? Is the 1/3 okay? 1 over 3, is that good? By the way, I agree with Emily and I agree with Harish. 0 doesn't work. 0 might look good on the face of it, but it doesn't work. How about the 1/3? Does the 1/3 work? Does the 1 over 3 work? Is it okay for me to use x as being 1 over 3? Looks good. Okay, and that is in fact the case, yes. So this one isn't good. Let's just cross that out. Oh, don't know why I'm using yellow, but we're using yellow anyway. So x equals 1/3, and in brackets, x equals 0 is extraneous. Okay, looks good. All right, let's see what else we got here. Yeah, this one looks interesting. Let's see what we're going to do with this. The log of x plus 5 is equal to 2 log x minus 1. Any thoughts on how we might be able to handle this one? We haven't had anyone quite like this before. So what do you think, folks? Yes, Jeremy? I think I understand what you're saying. So the power law of logs says that I could have written this as the log of x minus 1 squared, because that 2 in the front can actually be an exponent on the x minus 1. Ava agrees with that. Okay. So now we can drop the logs. I think Jeremy just said that a while ago. So it means that x plus 5 is actually equal to x minus 1 squared. Well, that certainly is not a solution. So what do I do now? Is my next question. That's not a solution. I don't know what x is yet. I still don't know what x is. Move everything to the left, you're saying. Expand the x minus 1. Move it to the left, Ava is saying. Okay, well, let's expand the x minus 1 first. So that would be x squared minus 2x plus 1. Okay, so you're saying move everything to the left. Okay, all right, we can do that. So that's going to give me minus x squared plus 2x minus 1 plus x plus 5 equals 0. Since you wanted me to move everything to the left, I've done that. So everything that I had on the right is changing sign and going on to the left-hand side. So it's minus x squared plus 2x minus 1, and then the plus the x and plus 5. Okay, so I'm assuming you want me now to simplify this. That's what I'm assuming. All right, so I'm going to go ahead and do that. So minus x squared. So the 2x and the x are going to be plus 3x. The minus 1 and the 5 is going to give me 4 equals 0. So now what? That's a little awkward with that minus in the front. All right, so are there any ideas as to how we deal with that? That minus in the front? Looking to you now. I'm stuck. Multiply by minus 1, Harish says. Everything on the left or on the right? I mean, which side are we multiplying here, Harish? So we can just multiply on one side of an equation. Is that okay? I didn't know we could do that. I thought you had to do it on both sides. So we're doing both sides. Ah, okay. But what happens when you multiply the right-hand side of this equation by minus 1, though? The right-hand side is a 0 right now. What do you have on that right-hand side after you multiply by the minus 1? It's still 0. Thank you, Ava, and thank you, Harish. So that's exactly what we're going to do. We're going to multiply both sides, the whole equation, by a minus 1. Or another way of looking at it is divide the whole thing by minus 1. So multiply by minus 1. So times minus 1. Okay. So left side becomes positive x squared minus 3x minus 4, but it's still equal to 0. Right? Because anything times 0 is still 0. So it's the same solution you'd get by just simply, and what we've really essentially done is just change all the signs. As long as it was equal to 0, set equal to 0, then just change all the signs. What was negative becomes positive. What was positive becomes negative. Okay. So can we factor this is the question. And can I get you to help me with that, please? Right? Can you factor what's there now? Right, I need your help, folks. I need you to chime in there. So minus 4 and 1. Okay. So x minus 4 and x, I guess, plus 1 is what I'm hearing, equals 0. And I agree. Of course, I agree. So what I'm going to do now is I'm going to go ahead and get two solutions. X minus 4 equals 0 and x plus 1 equals 0, which means x is equal to 4 and x equals minus 1. Okay, good enough, good enough. But does that work? Let's go back and have a look. So let's put in the 4 first. So the log of 4 plus 5 and 4 minus 1. I'm going to give a thumbs up on that. I'm going to say that's good to go. I don't see an issue with that whatsoever. Let's try, so I'm going to say a big check mark beside that one. Let's try the minus 1. Minus 1 plus 5, well, that's okay over here. Minus 1, that's not going to work over here. Okay, so even though you're talking about, yeah, you're going to square this though, the original equation, and we have to go back to the original, the minus 1 is going to cause a problem. So we have to say that this one is no go. And that the only solution is x equals 4 only. X equals minus 1 is extraneous. As good as it looked on paper, it's a no-go. What if the original was, okay, in that case, and that's a good question, Jerry. If the original had been that, then I'd have said we're good. All right, so even though they're equivalent, we always look at the original to take our cues and to figure out whether the number that you're looking at. When you graph, just so you know, if you graph both of those things on Desmos, if I have any time, I might be able to do it. They don't actually look the same. There's one part of the graph which is the same and one part which is not the same. So minus 1 to 5 those, yes, it would have been, right? If we have some time, I'm going to show them both here on a graph, right? So what I'm saying is I'm going to graph both 2 times the log of x minus 1 and log of x minus 1 squared. You might be surprised at what they look like on a graph. Similar, but not exactly the same. We have done questions like this before, which is to say, it's an exponential equation because the variable is in the exponent. Can anybody suggest how I would solve an equation that looks like the one that we're looking at right now? Is there any suggestion as to how I might be able to solve that? 4 to the power of x plus 5 is equal to 64 to the power of 4. Make them both have the same base, transform 64. And so both of you together are making a lot of sense. What I'm going to do is I'm going to take that 4 and leave it as 4 to the power of x plus 5. But then I'm going to make that 64 4 to the power of something. What thing is that? That's the same thing as 64. 4 to the power of 3. Good. Okay. And by the way, when I raise one power to another power, I can multiply those two exponents together. So this is actually 4 to the power of 3x. So 4 to the power of x plus 5 is equal to 4 to the power of 3x. Thank you, Emily and Joel. All right. So here's something that we just talked about a few minutes ago. If they both have the same base, which they do, then I don't need that base anymore. Right? I can just take the exponents and set them equal to each other. So it means that x plus 5 is equal to 3x. And then I can bring that 3x over to the left. So I'm going to say that x plus 5 minus 3x is equal to 0. And in fact, I can now say that x, well, let's just put these two together. Minus, all right, hang on. Minus 2x is equal to minus 5. I brought the 5 over onto the right-hand side, but as a negative. So therefore, x is equal to 5 over 2. So there you go. There's an answer that works. Now, we don't generally have to check. There can never be an extraneous number for these, right? No, because you're not trying to find the log of anything. You're just raising to a power, and therefore you should, generally speaking, no, there shouldn't be extraneous answers for questions like these. All right, so x is equal to 5 over 2 would be the correct solution for that one. Let's try this one here. Let me move this down. Now, I can't make these two have a base of 4, and I can't make these two have a base of 8. So what, thank you, Ava, by the way, I just saw that you put the answer in. So what do I do in a case like this, right? So Joel and so make them both have a base of 2. Thanks, Emily, and thanks, Joel. Okay, so that's what we're going to do. We're going to say that that 4 can be written as 2 to the power of 2, still to the power of 2x. And that 8 can be written as 2 to the power of 3 to the power of x minus 3. Okay. Now let's use the same thing we just learned a few minutes ago, that if we have a power to another exponent, we just multiply those two exponents together. So it's 2 to the power of 4x is equal to 2 to the power, okay, that 3 gets multiplied by both the x and the minus 3. So that's 2 to the power of 3x minus 9. Sometimes I've seen students make the mistake of thinking it's just 3x minus 3, but you have to multiply the 3 by both the x and the minus 3. So there you go. So now we can go ahead and drop the bases and say that 4x is equal to 3x minus 9. Bring that 3x over. So 4x minus 3x is equal to minus 9. And therefore, x equals minus 9. And I'm going fairly quickly here, because I think I'm doing questions that we are hopefully reasonably familiar with. So let's move on. Uh-oh. These ones that we just did were fine. But what just happened? What just happened that's so different from everything that we did before? And what's the problem now, folks? Right, everything was working smoothly and then we hit this bump. What's the bump here? Does anybody see what the problem is here? Nobody see no common base. Ah, geez, Harish, yeah, you're hurting us here. You're really taking the air out of our balloons. They're not multiples of each other. Yeah, yeah. So Do we just abandon ship and just say no, we can't do this one? Is that what we should do? Just put up the white flag and say, you know what? Isaac, you're funny. Okay, just throw in the towel. We can't do this. Unfortunately, that's not how we're gonna approach this one. Okay, that's not the way we're gonna do this. Okay, you guys are funny. All right. Does anybody have another suggestion apart from throwing in the towel? Right? Exponential form. What do you mean by that, Ava? Tell me what you mean by exponential. Are you saying both of these can be written in exponential form? The problem is that it's already exponential form, right? What we have now is exponential form. Okay, Noah's thinking log the two sides, and Ava's thinking, okay, actually, I think you know you're onto something. Let's take the log of the two sides of the equation. Because many times when you're trying to solve an exponential equation, logs are the way to go. So we're going to go ahead and take the log of the two sides. I'm going to take that advice. The log of 4 to the power of 2x minus 1 is equal to the log of 3 to the power of x plus 2. So that actually seems like a pretty good idea. So that's the log of the two sides. By the way, the two sides are base 10, just so you know, just FYI. Could I have taken a different base? Yeah, I could have taken the log base, I don't know, 4 if I wanted to, but that still doesn't help me out with the side that has a base of 3. So I decided to take with a base 10 log. That's why I took the base 10 log. So I've done that, but I'm still stuck. That didn't give me the answer. So any more suggestions? Okay, so let's see now. The log for both sides. I don't know if that might work. Move the right side to the left side. I'm seeing some great suggestions, but no. You're thinking change a base there, Jeremy, right? And I think Harish is thinking put them all together. But the problem is that we still have different logs, different that I don't think that's going to help us out very much. But how about that power law of logs? Okay, Jeremy, I see some interesting ideas there. But how about the power law of logs? And how might the power law of logs help us out in this case? Power law will work, yeah. In what sense? Well, how can I write these using that power law of logs? All right? How can I rewrite both sides of this using that power law of logs? Can anybody think of what that might look like? The log of 4 to the power of 2x plus 1 and the log of 3 to the power of x plus 2, right? How would it look if I use that power law? Please remember the power law. We've used the power law before. So yeah, there we go. So I'm going to say, put that exponent in the front. So 2x minus 1 multiplied by the log of 4 is equal to the x plus 2 times the log of 3. I like that. That actually seems to work quite well. Okay? We still don't know what x is. Okay? We can then evaluate the log of 3. We could, but we're not going to do that yet. And the log of 4, we could, but we're not going to do that yet. We're not going to do that just yet. Right? We're going to keep it as just a log of 3 and log of 4 because I might ask you to do a question like this and give me the answer in exact form, which would mean that if you took the log of 3 and log of 4, you're going to get some decimal answer, and that's not going to help me out very much. So what if I was trying to think of another strategy? Right? Can anybody suggest another? What about if I were to expand or to distribute, let me use a different word. What if I were to distribute that log 4 inside of the bracket and the log 3 inside of the bracket? Let me show you what I mean by that. What if I were to say 2x log 4 minus log 4 is equal to x log 3 plus 2 log 3. Does that make sense to everybody? All I did is I took that log 4 and I expanded it, or let me use a different word, and I distributed it into the bracket. Okay, does that look about right to everybody in the room? Right? Right, that log 4 multiplied by the 2x and that log 4 multiplied by the minus 1. All right, does everybody see where I'm going with that? And then the log 3 times the x and the log 3 times the 2. I also want to make sure everybody's following me on this because I haven't seen any reaction from the room yet. All right, let me do this. Let me put some lines there to help you out. This times this, and this times that. This times this, and that times that. Does everybody see what I'm doing here now? All right, I'm just distributing the log 4 into the bracket and the log 3 into the bracket. No, people still not sure what I'm doing here? Keontae? Okay, all right. Aliza, go ahead. You have something to say? Okay, Aliza, you want to put your mic on mute, please, then? Unless you have a question. All right, Aliza, I'm going to put your mic on mute. Okay, so I just have to put Aliza on mute there. Okay. All right, so that hasn't solved our problem yet. That still hasn't solved it. I still have the x floating around there, and it's not there yet. Any ideas as to where we can go? Any ideas as to where we can go? All right, so in the interest of time, because we're at 2:31 now, don't know where to go next. Okay, I'm thinking, why don't we get all our x's together in one side of the equation? That might be useful. So I'm going to go ahead and take the 2x log 4. Don't know why it doesn't matter if I'm using red. Log 4, and I'm going to minus from that the x log 3, right? By just taking the side that was on the right and putting it on the left. Then put the other stuff which doesn't have the x's. I want to put that on the right side is equal to 2 log 3 plus log 4. All right, what do you think, folks? Does that sound about right to you? All the terms, remember, I'm trying to isolate the x. That's my goal. I want that x on its own. So I'm going to put all the terms with x on one side and everything else that doesn't have an x, I'm going to put it on the other side. Okay, thank you, Jeremy, for that reaction. So, okay. Does that bring us closer to solving for x? What's that critical next step that we need now to eventually isolate that x? Can anybody see what that next step might be? Now, x are all together now, right? So because they're all together, that might actually give us a direction to go in to get that x on its own. Product law? No, no, no. How about if we factored out that x on the left-hand side, right? Isn't x a common factor of the stuff on the left-hand side? Thank you, Keontae, by the way. I appreciate that. And Jeremy, right? I appreciate all the ones who are making an effort to interact. But let's factor out that x. What's left when I factor out that x? Divide x into both of those terms on the left. And you tell me what's left after I factor out that x. So 2 log 4 minus log 3. Okay, good. So 2 log 4 minus log 3. I agree. And that's still equal to 2 log 3 plus log 4. I agree with all of that. I hope the next step is obvious now. I want that x on its own, and it's almost there. It's just x times something is equal to something else. Divide both sides absolutely by what you're multiplying the x by. Absolutely. So x is therefore equal to 2 log 3 plus log 4 divided by 2 log 4 minus log 3. Does everybody see what I just did there? Right? I'm trying to get to that log, sorry, that x on its own. If you're not sure, please ask me to go over it again. Right? I have x times something else. Now, let me just point that out. I have x times this thing right here is equal to that. Well, how about if I just divided both sides by this 2 log 4 minus log 3? How about if I did that? Right? I just have to be sure that let me call out a couple of people here on that because I'm not getting enough reaction from the room. Some people, yes, and a lot of people, no. Right? There's some people who haven't heard anything from the whole class. Rachel, how about you? Rachel, does that make sense? We put in an exponential form from here. Yeah, we're going to get to that in a minute. Okay, all right. So what we can do is we can simplify this a little bit more, and we should, if I give you a question like this on a test, because one thing we could say is that that 2 that's in front of the log 3, that could actually be the log of 3 squared. Can we agree on that? Plus the log of 4 over, and I can do the same thing with the denominator, the log of 4 squared minus the log of 3. All right, everybody sees that so far? No, I can go further. I can go even further. Remember, the log of a product is equal to log of the two sums. So that x could be the log of the 3 squared times the 4 over the log of the 4 squared divided by the 3. All right, have I lost anybody on that? The log of a quotient is the same as the log of the difference, which means at the top of this will be the log of, let's see now, 9 4 is 36 over the log of 16 over 3. If I asked you for this to, no, not in this case. No, we can't do that. No, it's not like you're saying this is equal to this. No, you can't do that. Right? So this is what x is equal to. This is what x itself is equal to. That's what this is. Why? Okay. Let's see how we can put this now. It's when I have that the log of one thing is equal to the log of something else, then yes, you can do that. But you're not saying that. You're saying the log of 36 divided by the log of 16 over 3. That's a complete different thing. It's not like you're saying this is equal to this. What you are saying is the log of 36 over the log of 16 over 3 is equal to x. Right? So that's why that's different from this. That is different in the 2 minutes that we have remaining. Let me go back a bit here from something like, actually, that was on the previous thing that we had, right? When you have two things across each other that are equal, then that's different from what we have here, which is where we're saying that this divided by this is equal to x. It's not we're saying that this is equal to this. We're not saying that at all. Do you see what I'm saying, Jeremy? Do you see why you can't just simply take away the logs? You're thinking, just take away the log to the top. No, you can't cancel the logs like that. The only time we can cancel logs is when the log of one thing is equal to the log of something else. Okay? We make 6 over 3 the 6 over 3 the base of the bottom. No, we're just saying it's a log of 16 over 3. That's all that is. Whatever 16 over 3 is, that's what it is. Could we change a base on this? Well, you could. I see. You actually just what Ava is saying. Yes, Ava, you're right. Now that I think about what you just said, you're right. This could be written as, yeah, you're right. If you use that change of base formula, that could be the log base 16 over 3. It's kind of a strange thing to be talking about, of 36. Yes, that I accept. Ava, I'm going to give you full props to that. That's absolutely true. We could change a base on that. We could, in fact, just at a base of 16 over 3 is that kind of an odd base to use, But yeah, that answer would now be right. Looks much cleaner. Okay. All right, Chianti, I hear you. I hear it. Looks much cleaner. She obviously prefers what we have now to whatever. I would have given you this answer, but yeah, this answer is absolutely true. I'll give April props on that. All right.